All right, guys, STAT1800, more on chi-square. Give you a problem. There's a little bit of a spin to this, but we'll figure it out together, right? So a digital, I'm not going to read to you, but I'm just going to read enough to get it going. A digital CEO is one of the 5 behaviors important to raising an organization's digital IQ. So apparently they did a survey of different industries, and they found out that 80% of automobile, 82% of healthcare, 70% of financial services, 59% of retail, and 76% of technology execs say their CEOs are active champions of using digital technology. So these results were based on 500 business IT executives in each of the 5 industries: technology, retail, financial, health, and automobile. All right, so at the .zero .05 level, is there evidence of a difference among industries with respect to the proportion of executives that say their CEOs are active champions of using digital technology? Now, when you look at a problem like this, you know, when we're trying to learn something, hopefully, you let your professor teach you something, and hopefully in this case you let me teach you something. So it's tempting and very much a reasonable approach to look at a previous problem that we've done and kind of mold it, adapt it, if you will, to this new problem. Unfortunately, everything we've done before has either had raw data or a contingency table. But what we can do is we can take what we've done before, and we've seen that we can have our best luck when we start with a contingency table. Now, so it looks like that the result of the question is either they are or they are not an active champion of using digital technology. And we're across the industries of automobile, healthcare, financial, retail, and the final one is technology. Now, we know that in the auto that 80% of the 500, because guys, if you go back again to the problem, 500 business IT execs in each of the 5 industries were actually sampled. So 80% of 500 tells me that 400 of the auto, 0.8 times 500 gives you 400. So guys, that tells me that 100 had to say no. The next statement was 82% of healthcare. So 500 times 0.82 is 410. So that tells me that 90 had to say no. 70% of financial services, so that's going to be 350. And 150 that said no. Because again, guys, each one of these have to add up to 500, because 500 were the total that were sampled. Retail, 59%, so take 0.59 times 500. We get 295. So that tells me that 205 must have said no. And in technology, 76% of the 500. I can do this in my head, but I don't want to make a silly mistake. So 120 said no. So guys, what we've done now is we've taken the information of the problem, and we now have something that looks like what we've done before. So just like before, we're going to set up that our proportion of auto will be equal to our proportion of health, will be equal to our proportion for financial, will be equal to our proportion for retail, equal to our proportion for technology. Our alternative, at least one pair, is different. Guys, let's test at 0.05. So, guys, we're now going to get out of here. We're going to go to a blank stat crunch. And so I'm going to give my headings first. So response, auto, health, as I promise you, I can spell health, financial, retail, and technology. All right, so let's go just like we did in the table, yes and no. This is the boring part. 350, 295, I believe, yes, and 380. And then 100. We could write an expression here, but it's probably just as easy to type in the 5 numbers. All right, so gang, let's double check our entries because we don't want to get anything wrong. 410, 350, 295, 380. Yeah. So guys, stat contingency table with summary. So our columns are going to be everything from auto down to technology, and our row will be response. I want my expected cell count, and I want my contribution to chi-square. I want to, because I think we're going to get a statistically significant result here. And since we have we don't have a 2x2, we don't worry about Fisher's exact test. Compute. And just as we would expect, we have a kind of what I expected, just looking at the difference of the percentages, we do have a statistically significant result. Now, these bottom numbers give you a contributing factor. And typically what you can do, you can look at those and eyeball them, and any of them that are above 2 significantly impact the chi-square. So the biggest difference is in retail. This 38.98, that tells us that of the total 8789, if you add all these numbers in the parentheses, all these numbers will add up to 87.89. So this 38.98 was the biggest contributor to the chi-square statistic. So that was the biggest difference between what we observed and what we expected under a true null hypothesis. The second biggest contributor, it looks like, was the 14.13. So this retail has me concerned with, essentially what I'm trying to say, and I'm not saying it very well, essentially what I'm trying to say is that the retail appears to be statistically significantly different than the other percentages. So, guys, that's kind of where we stand. Let me just summarize, give you a flow chart for what we're doing here. If we have a proportion problem, tell you what, let me grab my book here. So if we have categorical data, all right, let me get out of this and get you back over here. So, gang, if we have categorical data, which deals with contingency tables, we can do chi-square test of independence. We can do these for 2 by 2 tables, 2 by C tables, R by C tables. And we can also do tests for proportions. Now, if this test for proportion, if we have one sample, then as I've taught you before, we do a z-test. Remember these where we say that the proportion of people in a particular population, let's say it's 92%, and we want to test that against a proportion being not equal to 92%, we just use a z-test like I taught you before. If we have 2 or more, which I've been illustrating in these videos, then you're just going to do a chi-square test for props. So if we have 2, then each of those is going to be P1 equal pi 1 equal pi 2. If we have 3, pi 1 equal pi 2 equal pi 3. And guys, you can generalize from there clearly. So guys, I think you have to agree with me. I guess your homework assignments will dictate the final answer, but I think you have to agree with me that these are a lot easier than ANOVA, especially a lot easier than 2 sample quantitative problems that we ran into a couple weeks ago. So guys, I'm done. This is the final video on chi-square, so I hope you guys are doing well, and keep watching those videos, and well, that's all I'm going to say. Take care.